What a spectrograph does tends to be something that confuses people, because when we think of astronomy, the common person will think of images, of beautiful images that you see in the sky. However, a spectrograph, it gives you another degree of detail over the properties of the objects we're observing. Images, they give you all the spatial information of an object. Imagine a galaxy. You can see its central part, you can see the arms of the galaxy, you can see the colors, right? If you observe in different bands. Now, think of the colors of different bands that you're observing in images, and you just co-add them, and then you see something that is blue, something that is red, something that is green. A spectrograph does this in a much broader range, right? You start separating what's red, what's blue, what's green into much finer details, into detailed wavelengths. The more resolution that you do this in, the more detail you can get of the astronomical object you're understanding.
A spectrograph is a device that takes light from an object, so let's say like a star, for example, and it takes that light in, and then it spreads it out into a spectrum, or what we'd normally refer to as a rainbow. So in this case, you divide up that white light into all the different component colors that make up that light, and then you will, if you get a high resolution rainbow, you start to see which light is there and which light is missing, and from that information you can understand what the chemical processes are that create that light, so what a star is made from, that kind of thing.
I can give you examples of this. So if you're observing a star, what you get on the spectra, what you're capturing in a spectrum, is what materials, what abundances were in the atmospheres of the star that you're observing. So the light is emitted and it goes through the different layers of the atmosphere, and things get absorbed in different amounts. This tells you, when we collect the spectrum, we get signatures of this absorption that has happened, and it tells us, oh, this is the amount of a given element that is present in this particular star. Chemical abundances, which is what you recover from these stars in when you take a spectrum, it's like the DNA of a star. So you can reconstruct the history of how this star came to be, and if you do it for many stars, going back to the multi-object, you start reconstructing everything about the surrounding environment where these stars are being born, what has happened by then. And we use simulations with very detailed theory, right, to then reconstruct the history of that region of the galaxy. Then if you do it for large parts of the galaxy, you start understanding the galaxy as a whole. And if you do it for multiple galaxies, you start to understand how galaxies form and evolve throughout the entirety of cosmic time.